Probability and How It Minimizes Uncertainty by Kelsey Eaton and Leah Hall. So, a brief introduction is probability is an essential part of our everyday lives. Our math textbook even defines it as the foundation of what we think is common sense. We use it in everything we do, like figuring out if it will rain or not, if we will get a parking space during a busy time on campus, or if we have to wait in line for a coffee during the breakfast rush. Concepts like these are everyday dilemmas that can easily be predicted through probability. By using what we know about probability and the likelihood of an event happening, we can be prepared for the future and make better decisions. So, what is probability? Probability is the branch of mathematics dealing with the occurrence of a certain event. In other words, probability is the extent in which something is likely to happen. It is typically measured in decimal or fraction form spanning from 0 to 1. A brief history of probability is probability was first studied as a concept in the early 17th century when applied to gambling and betting on numbers. This practice would later evolve into the present-day studies of mathematicians dealing with random events. Famous 17th century French gambler and nobleman Anton Gombaud would bet that there would be at least one pair of sixes in 24 consecutive rolls of a pair of dice. Blaise Pascal and Pierre de Fermat, two well-known mathematicians of the time, helped him understand that this theory was not extremely probable. The probability of at least one pair of double sixes in 24 consecutive rolls of a pair of dice is roughly equal to about 0.49, meaning that it was almost a 50-50 probability, and that Gombaud would lose more than he would win when betting on it. This conclusion began the basis of what probability stands for and would be used when calculating the unknown. So some key concepts and definitions that the chapter goes over is a measure of likelihood, which is the concept of dividing the numbers of successful outcomes by the total number of the possible outcomes, and that leads into the equation for probability, which is the probability of an event E occurring is equal to N over T, where N is the number of different outcomes in E, and that is all over T, which is the total number of equally likely outcomes. Then there's relative frequency, which is the number of times an outcome occurred, all over the total number of times the experiment was repeated. Then lastly, we have it either happens or it doesn't, which is the probability that the event E will happen is equal to 1 minus the probability that the event E will not happen. Now we'll walk through some problems regarding these key concepts and definitions. In problem 1, we'll use the equation for probability, which is N over T. In problem 2, we'll use the concept of relative frequency, which again is the number of times that an outcome occurred all over the number of times the experiment was repeated, and the concept of it either happens or it doesn't, which is the probability that the event E will happen is equal to 1 minus the probability that the event will not happen.
Problem number 1. Let's say you have a dime and a penny. Flip them both, noting whether each coin lands heads up or tails up. List all the possible outcomes. Let E be the event that you get at least one head. List all the outcomes that give E. What is the probability that E occurs? The chart below shows all possible outcomes for flipping both the dime and the penny. There are 4 possible total outcomes of flipping the 2 coins. If E equals the probability that we get at least one head, that happens in 3 out of 4 of these outcomes. Those outcomes being heads and heads and tails and heads. So the probability of flipping at least one head is 3/4 or 0.75. So 75% of the time, E is likely to occur. Problem number 2. Let's say that you choose 3 people at random. What is the probability that they all were born on February 1st? It's easier to first figure out what the probability of the 3 of them having different birthdays is, rather than the same one. We first have to figure out how many possible triples of dates there are for birthdays of any 3 people. 365 possible days for the first person, 365 for the second, and 365 for the third. Using those numbers, we can find that 365 times 365 times 365 equals 48,627,125. So there are that many amount of different triples of dates. Regarding this number, we now have to figure out how many of these dates have 3 different dates within them. The first person's birthday can be any date, so there are 365 possibilities for that person. But the second person's birthday can be any date except for the first person's date, so the second person has 364 possibilities. The third person cannot have the dates of either the first or second person, which leaves them 363 possibilities. Regarding these numbers, we can see that 365 times 364 times 363 equals 48,228,180. Taking these numbers and regarding the 3 individuals, the probability that they have 3 different birthdays is equal to 365 times 364 times 363 divided by 365 times 365 times 365, which equals 0.9917. Since this is the probability that all 3 of the individuals do not have the same birthday, in order to find out the probability that they all have the same date, we need to take this number away from 1. 1 minus 0.9917 equals 0.0082. Therefore, the probability of randomly picking 3 individuals and all of them sharing the same birthday of February 1st is 0.0082, which is highly unlikely. In conclusion, while we may not think of it as an everyday task, probability is definitely a useful practice for us to have under our belts. We can use this concept to determine what the future may hold for us and to decide how to act based on what is probable to occur and what is not. By reviewing this section and taking this course, we have learned that probability is a crucial concept to our existence. It enables us to know the likelihood of events and prepares us for our future in an essential way. These are our sources that we used, and thank you all for watching.